Mentally math!
Let's get mental!
All right.
That was good. Let's get mental!
Okay, let's get started. Adjust this so that it's a little easier to read.
I love the positive and negative ones. Yeah.
Yeah, those are fun, I think.
So satisfying. Kind of.
Right on. I'm glad you feel that way.
Oh.
Okay, so I'm sure people are at least a couple ahead of me at this point. Okay, then I'll get started. Okay, so this is just the equivalent of combining the value of -3 with -12, which is -15. And then here we're just dividing by 1,000, or 3 boingies to the left. Boingy, boingy, boingy. And so that'll be 0, 0, 0. Or 5. And then I can actually just kind of look at this as 2,400 divided by 30 is how I could look at that, which would be 80. I'm not sure whether it's my stylus pen or something with my screen, but lately when I've been writing on this, there's kind of little gaps in the writing, so hopefully there won't be too much of that going on. Okay, so I can look at this as times 2 is 24, then half times another half would be 30. Oh, okay, right on. Then 50 centimeters is half a meter, otherwise known as 5/10 of a meter. And so very, very bright, yes. Too bright. We'll be fiddling around with that a little more. Then, so 3/4 of 36. So we can think that 1/4 is 9. So 3 of those would be $27. Prime factorization of 16 would be 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Oh, you can do that, but it doesn't say with it does not say with exponents though. So actually, if it doesn't say with exponents, it should look like this.
Only when it allows you to do it with exponents.
Yeah. So that would not be a great answer for that, because we use prime factorization for things like cross-canceling goodness, and the exponent is not always useful for that.
4 times 4 work?
No, because you would not have finished the prime factorization. 4 times 4, those are two composite numbers, not prime numbers.
I don't really get what to do with prime factorization.
Prime factorization is what prime numbers would be multiplied together to get that number. So it's basically breaking it down to its most simple components, and so in this case, it's 2. Yes, because otherwise, if it's composite numbers, you can break it down even further. So it's the most basic little numerical building blocks you can use to multiply together to get that number. Does that make sense?
Yes.
And then you can use that information for various useful things. For getting least common multiple, greatest common factor, simplifying really tricky fractions, things like that. Okay, then a good question. All right. So let's see, total. So 8%. I can think 8/100 times 30 would be $2.40. Right? So $2.40 plus 30 would be $32.40. Is there a question?
Yeah, no, I just said, well, I did 8% of 80% of 10 of 100%.
Uh-huh.
I multiplied 100 by 3, and then then I look at that as 80 times 3, and then I got 240.
Mm-hmm.
So then I just kind of multiplied them both by 3, and then I got that.
Okay. Okay. Well, you know, whatever your own mentally math path to get to the same place is totally fine.
Percentage is cool with dollars because dollars are basically 100 cents.
Right.
So percent will basically just be 90 cents.
Right. Right. All right. So today, lesson 71: finding the whole group when a fraction is known. So in this case, we are finding out like what exactly, if you know what the fraction of something is, how can you find what like the whole group that it's taken from is, and other ways to use that information. Alright, so in this case, when Juan finished page 51, he was 3/8 of the way through his book. The book had how many pages? So there's a couple ways going about this. So in this problem, we're looking for just the total number, which is pretty simple. There are a couple of methods that you could go about this. In fact, example 2 is method number 2. In case when I do this, you go, hey, but I know a much simpler way to do that. That's probably example 2.
Yeah.
So, but for this one, we're going to diagram it. So just so that we can visualize what's going on. So we're talking about eighths. So our diagram will be made up of eighths. The key with these is to find out what your fractional unit is. Oh, that's it. Okay, no, these are not exactly even. All right. So there we have our eighths mapped out, and we can think that 3 of these eighths would equal 51 pages. So our question here is how can we find out what the unit is for each eighth? And then, well, we can multiply that times 8 to get our answer. So, if I know that 3 of those eighths are divided amongst 51 pages, then how much is each eighth? How can we find that out? We know that there's 3 slots. We know they must be divided evenly 3 ways. And I already just told you, yes.
51 divided by 3?
Ta-da! Divide 51 by 3. Which is, everyone can probably tell me, is?
17.
17. And so once you've got this information, there's probably a couple of ways you could go about figuring out the answer, but really the simplest way is just multiply 17 times 8. And there we go. Ta-da! Yeah.
Mr. Hunter,
Uh-huh.
we do this with equivalent ratios?
Why? Sort of. In fact, it's even simpler than equivalent ratios. So method number 2 here is just this.
Yeah.
since all we're trying to do is get the whole, then a simple equation that's basically saying 3/8 of the pages of p, of our variable p, is 51. So we can just solve for that. So to find out what the total is. Essentially, 3/8 times blah 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 equals 51. So what does p equal? So what do we need to do to finish this equation? To simplify this equation? Rhymes with schmemrical? No. Inverse operation. Yeah. Inverse operation. In this case, we are using the reciprocal. So we are going to multiply each side by the reciprocal. So we do that. We've got 1p, otherwise known as p, and then we can just multiply that by 8/3, and well, basically a little bit of cross-canceling goodness. And you know where this gets us? Exactly where we were last time. 17 times 8.
Really?
Getting us our 136 pages. So either way, I mean, this is just so we can just visualize what's going on. Right? If we just jump straight to this, it might not be obvious, like, what's really going on with these numbers. And if there's an empty seat, you can move wherever you like.
There's always another way to do it.
Yeah.
Some other ways don't.
I mean, if you can see easier here, you can come here. Yeah. Yeah. If there's an empty seat that's in a better spot to see, then please help yourself out with that. Yep.
There's always for most questions, there's another easy way that's not usually used, but that only applies to that certain question.
Right.
In this question, you could have multiplied the 3/8 by 2 to get 3/4 is equal to 102. And then you could have just added 34 to 102, and you would get 1.
Well, sometimes you can just intuitively find a path that gets you to the correct answer that you know that wouldn't necessarily work for every problem.
Yeah.
Sure. As long as you realize that. Okay, so here we're going to take it to the next level a little bit. We're not trying to get the total. We're trying to get some more information out of this that, using this. So, as Sakura went from room to room, she found that, and I'm wondering where she was with that has this many lights.
Yeah.
She found that 3/5 of the lights were on and that 30 lights were off. She's either got a really big house or she's walking around a hotel or, yeah, a school, very big school or something. Okay, and what's she doing? If she's at a hotel. What's she doing wandering around other people's hotel rooms? Anyway, so anyway, I'm not gonna try to overthink this. But anyway, so she found that 3/5 of the lights were on and 30 lights were off. How many lights were on? So we're gonna diagram this one.
Oh my god, this is mental math.
It is kind of mentally math, but you know, I know it wasn't completely intuitive to everybody in the last group, so maybe it's good to diagram this so that we can see exactly what's going on. Okay, so we're working in fifths, so we're going to diagram fifths, and then we know that we're going to take the information that we have and figure out what information we don't have. So we know of these 3/5.
Base.
Yeah. That we know that these represent the lights that are on.
That's her.
And then down here, we know that the... Oh, okay. Fine.
That looks like
That one's not so great.
That looks her. That looks like
We know that 30 are off. So really the key here is we want, once again, we want to find our fractional unit here. And so if we know that 2 of our fifths add up to 30, then what can we do with the number 30 to figure out what each of our units is? Okay, you've already answered. Let's just get someone who hasn't answered. Yeah.
you divide by 2.
Just divide by 2. So now we know that all of our units are 15. Of course, what we're trying to figure out is this group. But now we know those are 3/5, so we just take the 15 and we do what? Yes?
Multiply 15 by 3.
Multiply 15 by 3.
45.
Yeah, it's not rocket science, huh?
Why do you always say that? Like it's not rocket science.
Like it's not that hard.
It's very complicated.
It's not very complicated.
But do people feel study?
Okay, so then we know 45 lights are... Oh, whoops. I did. Oh, yeah, are on.
Mr. Crabtree, is there an easier, is there like a short equation to solve this? Or
A shorter equation to solve this. Well, why don't you think about this?
It might not be applying forever question, but...
Well, you know, one thing we could say is, if we know we can take this and we know that if 3/5 are on and 30 lights are off, then we know that 2 to the 5ths times L equals 30, right?
Yeah.
So we can work from there.
Well, technically, your mind should be able to solve it.
Ooh, well, yeah. I mean, there's some mental steps you can make, but you can set it up as an equation, and
Mr. Crabtree, if you were to do it like this, you would be able to do like the satisfying thing.
and then you can. This will just kind of get you to the same spot. Yeah. So anyway, so you could use this to get the total, and then you work away from there. Okay, so let's do one more example here. 5/8. The clowns. 5/8 of the clowns. See if you can figure this one out ahead of me. 5/8 of the clowns had happy faces. If 15 clowns did not have happy faces, how many clowns were there in all?
Even more disturbing. Oh my god.
Mm-hmm.
I think she hates clowns.
Oh.
Happy face one.
I chose this one because it was cringier than the other ones.
He's actually named for being afraid of clowns, but I forgot it because it's too hard.
Okay.
It's really cringy.
Okay, so I'm just gonna diagram it.
Is it okay if I did
Okay.
show it on my window?
Yeah, sure. However you wanted to do it. I'm gonna diagram it. You can try to figure it out any way you can. You just try to do it faster than me. Which, if I'm diagramming, means I'm going real slow.
Can I please use the restroom?
Okay. Alright, so 1, 2, 3, 4, 5. Okay, so 5/8 are happy, and that leaves 3 A's that are sad, angry, homicidal.
What?
Oh, what? Oh, we'll just say sad. Okay. Okay, just sad. Just sad's fine. Anyway, no. That's not. Okay, that's even worse. Okay, so if 15 clowns. Okay, and then we know that of the ones that are not happy. However, whatever their situation is, we know there are 15 of those. So, what's our fractional unit? Yes. Huh? We are dividing, and so we are dividing 15 by 3, which makes our fractional unit 5. So at that point, we just need to know how many clowns are we dealing with here. And so what we end up with is, since we know our fractional unit is 5, we know that there are 8 groups of 5. We just need to do our 8 times 5 to know that we are dealing with 40 clowns. And they're on their way here right now. Okay, that's the lesson.
7